Evening all of you. I hope you all are doing well. So today we are going to understand the important concept of stimulated absorption, stimulated emission and the spontaneous emission. So for this what we'll consider the two energy levels E1 and E2. So in the first condition we'll consider that the atom is in the ground state. Okay, so look at here all of you. Initially we have considered that the atom is in the ground state. Okay, so it will provide a suitable energy to the atom, and that energy must be equal to the difference of the two energy level, that is E2 minus E1. So it will provide a suitable energy to this atom. The atom will jump to the higher energy state. So this phenomenon is known as stimulated absorption. Okay, in the second phenomenon what happened, atom goes to the high energy state. Okay, the lifetime of the excited state is 10 to the power minus 8 second. So after 10 to the power minus 8 second, the atom jump to the lower energy state. Okay, so look at here. Will provide a suitable energy to the atom which is in the ground state, then it will jump to the high energy state. Now when the atom reaches the high energy state, then after 10 to the power minus 8 second, because this is a lifetime of the atom in the excited state. Okay, so after 10 to the power minus 8 second, it will jump to the lower energy state with the emission of the same photon which it was absorbed initially during the stimulated absorption. Okay, so this phenomenon is known as a spontaneous emission. So in the two phenomenon what we have studied, that initially we have considered the atom in the ground state. We have provided a suitable energy to the atom due to which the atom jumped to the high energy state. So this phenomenon is simply called the stimulated absorption. Now when the atom reaches to the high energy state, then after t is equals to 10 to the power minus 8 second, because this is a lifetime of the atom in the excited state. After 10 to the power minus 8 second, the atom will jump to the lower energy state with the emission of the same photon. Okay, so this phenomenon is known as spontaneous emission because we haven't provided any energy in this phenomenon. That's why this phenomenon is known as spontaneous emission. Now in the third phenomenon, what is actually the third phenomenon is all about, we'll consider the atom in the excited state. Okay, that means it is already stimulated. So here the atom is already in the high energy state. Okay, it has some energy. So now if it is stimulated again, means it will provide a suitable energy to this atom which is already in the excited state, then it will jump to the lower energy state but with the emission of the two photon. Okay, and that the energy of these two photon will be the same. So this phenomenon is known as a stimulated emission. Okay, so in the stimulated emission what we will consider, that the atom should be in the higher energy state. That means it is already stimulated. So if it is already stimulated, it has some energy. Okay, and if it will provide a suitable energy to this atom, then it will jump to the lower energy state with the emission of the two photon. So this phenomenon is known as a stimulated emission. So in the upcoming videos I will tell you how we'll produce a laser, how it is possible to produce a laser by using the phenomenon of stimulated emission. Okay, so we'll use the third concept, that is a stimulated emission, in the production of the laser. So I hope you will you understand it very well. Thank you.